all that stuff that the wireless keypads do. Same. Okay. Failover behavior, we talked about that already. Talked about failover, configuration, we looked at that. Engraving is the same. Okay, let's get into the power supply now. So, how many keypads can be supported on a bus depends on where you put the bus power supply and how you wire it up. So I'm going to show you guys like 4 or 5 scenarios here. Okay, it uses RS-485. The gateway itself here's the gateway, so it's a half-size module, right? That's going to go in the panel. And let's talk about, first of all, bus cable recommendations. We recommend you guys use something like 18 gauge pair for power, 22 or 24 for twisted pair. You can use Cat 5 or Cat 6, but we don't recommend it because there's been some issues with wires coming out, just poor installation experience from our beta testers. So we're saying if you already installed that, you don't have to rip that all out, but certainly on future jobs, look at something like a Belden 1502R or 1502P. If those don't mean anything to you, basically that's just an 18 gauge and a 22 gauge all in a single jacket. Okay, is what those are. Now, let's talk about how many keypads you can do. If you wire the power supply and the gateway at the beginning of the bus, you can do 40 keypads in one direction for a maximum of 1,000 feet. 40 keypads for that single power supply and that gateway. Okay? If you do them in the middle, you can do 1,000 feet one way, 300 meters, 1,000 feet the other way, 300 meters, and 25 keypads per direction. Okay? So that's the second way you can do this. That's with a single power supply and a single gateway, a maximum of 50 keypads. If you do 2 power supplies and the gateway in the middle, you can do 40 keypads going 300 meters one way, 40 keypads going 300 meters the other way, up to 80 keypads then, okay, if this is in the middle. So if it's just this guy, 40 going one way. If it's in the middle with these two, 25 and 25. If it's 2 power supplies, 40 and 40. Gets even better. I'll show you here in a second. In fact, I'm going to skip to, oh, this is important. Loopback cables. Okay, we recommend that whenever possible you run a loopback cable, but don't terminate it. And here's the reason why. Let's say somebody in the construction process came along and put a nail right through that wire. Well, that's a bummer. Okay, a loopback cable allows you to have a fallback plan in case something like that happens. So what happens is if somebody did put a nail through the wire right there, and these keypads no longer communicate, you can now terminate that loopback cable so that it's connected to the gateway and it's connected to the final one in the chain here, and you make sure that this wire is now no longer part of the picture. You know, you get that out of the picture, you disconnect it from the next keypad. Okay. So now this gateway can talk both directions here, and your keypads are online. Okay. So that's just a fail-safe or a good rule of thumb that loopback serves as a, in case a nail does get put through a wire.
Are you open to go daisy?
To go daisy? Yes. Okay. These keypads, people say, can I home run them? Well, you can home run them back in a daisy chain manner. Okay. So we do star topology, but it's daisy chain star, and I'm going to show you that in like 2 seconds here. So this is a little different way of looking at what I showed you at the beginning, where we got the gateway and the power supply going to 40 keypads. Then I showed you gateway, power supply, 25 one direction, 25 the other direction. Then I showed you 2 power supplies, 40 direction, 40 the other direction. Now I'm going to show you a 4th option utilizing star topology. Okay, so we support 8 spokes coming off of 2 power supplies and a single gateway. Up to 8 spokes. If it's a single power supply and a single gateway, it's 4 spokes. Okay, but those spokes are daisy chained. Okay, so there isn't single keypad home run wiring coming back. It is a daisy. It's designed so that it goes from one keypad to another to another. So if you've got 2 power supplies, you can support up to 80 keypads. A single spoke can go 1,000 feet, and the total amount of cable for the 8 spokes cannot exceed 4,000 feet. So let me show you some pictures here. So we've got 1 gateway, 1 bus power supply. We've got 4 spokes coming off here. Each spoke can have 10 keypads up to 1,000 feet for a total of 4,000 feet in distance. Okay? But again, these are daisy chained. They're not all home run back. The only thing that home runs back is the final thing in the spoke line. Okay? Does that make sense to you guys? Now you add another power supply in here. Oh, this is just zooming in on this portion right here. So here's 2 spokes. Here's our 5th way. You add another power supply and you can do 8 spokes off that central location. So there is a key here that you got to remember. That second power supply, the ground has to be connected in to the same ground that the first power supply is connected into. So they both connect into the ground here on this gateway. Okay, the reason for that has to do with, I'm told, voltage differentials on the line, so that doesn't get screwed up if one's connected to one ground and another's connected to a completely different ground on a different circuit. Okay? So just make sure the ground wire goes into the bus Ethernet gateway and you should be good. So when you do it this way, you can do 4 spokes off one side, 4 spokes off the other, a maximum of 80 keypads, 10 keypads per daisy chain run with up to 4,000 feet total in the runs. That was a mouthful. Does that make sense to you guys? All right, so to recap, if you've got a single keypad or a single gateway power supply and you only go one direction, 40 keypads, 1,000 feet. You put it in the middle, 25 keypads one way, 25 keypads the other way, 50 total, 1,000 feet one way, 1,000 feet the other way. If you do it the third way with 2 power supplies and the keypad and the gateway in the middle, and you do star topology, you're going to be looking at 4 spokes per bus power supply. And those 4 spokes can each be 10 keypads or 1,000 feet. Or if you're doing 2 power supplies, they're 4,000 feet total on those. So you can have, one run be 1,000, another run be 1,000, another run be 200 feet, another run be 500 feet, as long as your total doesn't exceed the 4,000 feet for those 8 spokes. Whew. That was a lot to try and get through before guys run out. So it is 4:30. If you had to go, did everybody leave who needed to leave?
I'm going to go in a second. Couple of questions. Do you have, or are you going to have, a bus-wired sensor?
A bus-wired sensor. What would like a contact?
Motion, anything. Basically.
Okay. A bus-wired contact sensor or motion sensor or something?
Yeah.
Okay. That's a great suggestion. I don't know of anything right off the top of my head that we're doing anything like that, but...
So at the moment, any sensors you are sort of like a card access CP sensor?
Yeah, any sensors would be a third-party sensor introduced to that, or our own contacts, but they're going to be running back into like a controller, contact input on the controller.
Yeah. And what about blinds? What about 240 control blinds? So you've got up and down. Obviously, you can't have both circuits on at the same time.
Yep.
Some sort of interlink that allows you to do it.
Yeah. So his question, 240 volt control over blinds. Any thoughts there, Paul?
Not in this format here. Certainly be able to control those through normal relays, of course, but not through this panel lights.
What about band speed controls?
Band speed controls. Have you been here? Yeah. Same. I mean, we're in the same boat with that, right? It's. We don't have a good answer for you guys right now on that.
Are there any age terminators being 485 bus?
What's that?
Is there any age terminators being 485 bus?
So the last keypad in the chain basically is the termination point. So you don't need to add something beyond that.
There's no resistor or anything, just fixtures.
Yep. Yeah, good question. Yes.
One quick other question as well. We do a lot of Dynalight. With Dynalight, you can install the system, and before you even program a thing,
Yes.
any panel in the system will allow you to turn all lights on, all lights off.
Yes.
Is that something that Control4 can do?
No. So his question was, before you do any configuration or setup, Dynalight allows you to kind of install the keypads, if I'm understanding it correctly, and then each one of those will control.
Do it on all lights on function?
Yeah, and all lights on or off.
So if you need to test everything, you can go to any
Yeah.
panel, all lights on.
That doesn't exist in our world, as far as I know.
What
This
you're
one.
saying is you do that before you put it by using those shredder connectors on terminal strips. So you have spark is
Yeah, that's just using the circuits themselves. Yes. Yes. But there's no way to test out the wired keypads until you actually configure those in Composer. You add those, and if you stick around, I'll show you how to do that. But some of you guys got to go. All right. Let's see if we need to talk about this system diagram at all. You've got your controller talking to the Ethernet. Talking to the devices through the Ethernet switch. So there's some type of another switch here in this picture, but this switch is going to then talk to the panelized lighting. You've got your line power going to the power supply, which again, these are daisy chain keypads. Okay, I don't know how to beat that in your heads, but it's daisy chain, right? From keypad to keypad to keypad. Then you can also control these via Zigbee, okay, or the wired keypads, both. In fact, if you think about it, it's probably a good idea to try and plan in, especially in a larger job, not just all wired keypads, but maybe a few Zigbee keypads spread throughout, especially if you're going to have things like remotes and other Zigbee devices in the house. Because you could completely kill off any kind of a chance for a mesh if you just did wired keypad everything, right? So maybe, you decide when you're doing this, all right, every few rooms I'm going to do a Zigbee keypad in there so that I have at least some types of repeaters that are available for my Zigbee devices to latch on to. Otherwise, you end up having to put a whole lot of zaps throughout just to get your Zigbee working. Yes?
If you do that, and then it keypad tabs in the process.
Those other keypads? I don't see why not. So his question, you guys in the back maybe can help me. Can we power the Zigbee keypads off the bus power supply? The 48-volt power supply. I mean, it's going to send, I don't see why you couldn't right off the bat.
The great idea, if you need to put an extra slot in from there.
Yeah. Because it's just two wires from carrying power to that thing, and why can't you just,
We'll have to get it answered.
Yeah. That's a good question. Hey, look. I had ESPN just then. I knew what was coming up, right? All right, so mixing wired and wireless, probably the best mix of what you should do. Put a wired keypad at the main entrance to take advantage of the failover behavior of the wired keypad, wireless keypads in some of the areas to build out that mesh. All right, so let's talk about...
Why don't you make panelized lighting switches with or without Zigbee?
Zigbee repeaters. So that's been suggested.
Then if you get stuck when you've already done the wiring,
Yeah.
all you got to do is swap it out.
Yeah, to begin with, it's a cost issue consideration there to add the extra antennas in there and whatnot. So, but it is something that we're definitely thinking about. How do we make the mesh stronger with these types of situations? So whether that's another product or whether that's a different SKU for a wired keypad that has a Zigbee repeater in that. A Zigbee puck, whatever. All that stuff is sort of on the table right now.
Otherwise, you've got to plan it. Before you can even
You do. You really do have to plan what you're doing beforehand on this. It's not a seat of the pants on the fly thing. You've got to figure it out beforehand.
Yeah, you can do a lot of survey during construction, and then later on they put in steel walls.
Yeah.
And then you're steel lining on walls.
Yeah. But building in the Zigbee antenna into the wired keypad, interesting idea. Keypad placement. what we came across during beta testing is that because they're the only tactile connection to the panelized system, you're probably going to end up installing more than you originally thought. So that's hard to predict, but again, in all our beta installs, we've ended up, people have just put in more than they originally thought. Again, because it's got the failover, it's got the tactile response. You know, as much as we'd love for everybody just to, you know, maybe put touch panels in every single, you know, room, that doesn't always happen, right? Due to cost and other considerations. So.
How far back did the wired keypad is? Oh, there it is. Stuck.
It got stuck at the table with nobody on it.
Lost along the way.
So when you're thinking about keypads, you know, at the top and bottom of stairs, entrances to rooms, obviously, you know, typically where you'd find light switches normally. Showers, tubs, toilets, bedsides. How many of you guys do light switches next to bedsides so people don't have to get out of the bed to do it? I think that's fantastic. Right? I hate it when I'm, like, especially in hotels and things, where it makes me get up to control the lights. It's just so bothersome to me. Okay? It's just like, I just feel like checking out right then. No, I don't. But it's, you know, put them in places where they're convenient. Next to kitchen sinks, inside interior doors, closets, large rooms, you know, multiple locations. Where really, you know, what you want to think about is, where's the customer going to spend most of their time in this room, and put some type of way for them to control the devices in that room near them. Whether that's a touch panel or something in the wall, you know, if they're sitting in a den all the time in a lazy boy recliner, put something by the, you know, the recliner. Just think about where are they going to be in the, you know, not everybody has immediate access, like not everybody has the remote on them all the time, not everybody has their phone in their pocket all the time, although most people, it seems like, you know, bring the phone to bed with them, and, you know, it's right there next to them. All right, are there any national or local codes here for you guys that dictate how high you need to put a switch?
I think that system.
Okay, so nothing really you can kind of do. Is there a standard you guys typically want to do? Whatever they say? Yeah, we actually have, especially in like light commercial environments now, we have regulations where we can't install things like thermostats and other devices above the height that a person in a wheelchair could reach. And that's you know, against the law for us to do that in a light commercial environment. In a residence, we can get away with doing just about anything now, but in light commercial, it's very, very strict for us. Obviously, you're going to do it wherever they you know, is comfortable for them. So, if you're doing this for a family of everyone who's over, you know, 3 meters, well, they're not that tall. Everyone who's like 2.5 meters. Yes, you guys grow giants down here, right? Anyway, you know, you might adjust it. All right. Remember to account for molding around the door, wall thickness. You guys, we've got adjustable depth boxes that sometimes come in handy. All right. Obviously, you use keypads for controlling things other than lights, right? Music, locks, garage doors. I got to take this picture out. This is not a keypad that exists. Move along. These are not the keypads you're looking for. Okay. Let's see. Let's put it all together here. So, how does it go? Just a reminder, you've got your circuit breaker. You've got that going into your terminal blocks. Terminal blocks connect into the panel modules. The panel modules then feed your light loads, and the network connects into the panel modules as well via these Ethernet jacks. Simple, right? Easy, it's clean, works well. Then you've got, if you're doing hardwired lights, you've got your wired keypads going into the power supply and gateway, connecting to the network, and then that network connection is what tells these guys what got pressed. Zigbee works much the same way, you just don't have the hardwired keypads in there. So take that. Okay, we're not going to take a break. We are going to move on. talk about how this all comes together in Composer now. Okay, so like I said, a lot of what happens beforehand, before even any walls go up, is system design in Composer, so that the electrician has a document that they know where things are going. You know, how do they know which circuit goes where, which load gets connected to where? Well, Composer is used to help design that. Composer will also do the wattage calculations for you to make sure you're not overloading any particular module with too much lighting load. And so then it becomes sort of a juggling act. If you get a report that says, hey, this module's overloaded, then you can figure, well, maybe I'm going to route these two loads down to this and swap that one load up there, and then juggle things depending on what light loads are actually connected to this. So then when you're all done with that, the installation report can be printed out. If you're the electrician, great, you've got something to go on. If you're not the electrician, you can hand them the report. This is how I need you to wire this. And that all gets generated from Composer. Okay? So early stage planning, you want to obtain some type of lighting plan, what loads are going to be connected, and where you're going to put the panels in. So as you look at your lighting plan, you'll figure out how many loads are in this. You'll be able to actually define all of this in Composer and tell the electrician again where that lighting load is, where it's going to be run to, into which module, and so on. Ensure that your lighting legs are clearly identified, okay, with what's going in there, how is it being mounted, the wattage, where is it located again, is it dimmable, how many fixtures are in there, so that you can do a calculation on, I'm putting in 120 watts, 6 fixtures, so I can tell Composer that I'm going to have 720 watts connected to this particular circuit or this particular line load.
Is this outside of the Composer?
This is outside, kind of. You're figuring, but Composer gives you reports that are similar to this once you've inputted them. So we'll get there in a second here. You're going to determine what types of loads are in there. You're going to determine where the panels will be installed. Again, you can do it all in one, or you can do clusters. But you want to keep that that little noise factor in mind. It's not super loud, and they also require ventilation. So, keep that in mind when you're figuring out where to put those. So first thing is you're going to use Composer 2.5 or greater to do this. You're going to fire up Virtual Director, and you're going to start adding lights and modules and so on in a certain order to make it easiest for you, and I'll go over that order here. So install Composer, open up Virtual Director, create your rooms. Okay, so you're going to hit Virtual Director here. Add your new project, including floors, rooms, and so on. Include the rooms that you're going to install the panel into itself, the panel cabinets. Okay, so add all your rooms. You can set up your lighting defaults now. Where your nominal voltage, 240, 220, whatever you're using. You're dictating whether or not. Why do you think we have you check panelized modules in Control4 panel? What do you think that means? Yeah, so if you don't put it in Control4 panel, we're going to reduce the amount of available wattage that Composer is going to let you have on those panel modules, right? Because they're not going to be vented the same way that we've tested these things against. So if you put them in our panel, check that. If you don't check it, and it will reduce the amount of wattage that it's going to let you put through there. All right, so you create your rooms. Here we've got 5 rooms in here. Then you're going to add the drivers, first of all, for the lights. So when you're Composer, if you don't see these drivers right away in the lighting area, just right-click in the driver column and say Restore Default List. And then you'll see Light V2 pop up, where you'll get a dimmable light, a non-dimmable light, or a 0 to 10 volt light, and they'll all say panelized after them. Okay? The dimmable light is used for any line voltage dimmable light, and it can only be connected to the 8-channel dimmer module in Composer. The non-dimmable light can be connected to an 8-channel relay or an 8-channel dimmer if the wattage is low enough, and a 0 to 10 volt can be connected to both a 0 to 10 volt dimmer and an 8-channel relay at the same time to control that on and off function. Okay? So you put in the appropriate light type. So you're going to go add light drivers to the project in the appropriate rooms here. We've added, overhead lights, fan light, ceiling light, and so on. You can hover over that, and it'll have a pop-up on the model, whether that's the dimmer, the non-dimmable, or the 0 to 10 that you added. Because the drivers themselves, right, they look the same for all these. It all just looks like a light. Then, once you've done that, you complete what we call the load schedule. And this is where you're putting in the load number and the wattage. Okay. So, at the bottom here, under Advanced Properties, we allow you to put in a load number, and this can be alpha or numeric characters. And it can correspond to things like, on the lighting schedule that is associated with the blueprint, 04 and 001 refers to a certain light. Or you may want to adopt, floor, room, and light name. And again, you can do that you can spell it out, or you can do, floor 1, room 2, light 3. And that means the kitchen sconces. As long as this is just random, whatever you're going to make of it that makes sense to you and the electrician. Type it out, use numbers, whatever makes the most sense. But that's indicating what that light is. And then you're going to put the total wattage that light is going to be drawing. Okay? So how do you get that? You take the number of fixtures, you multiply that by the light wattage on each fixture, or bulb, or load, and that's what you put in there. What was the rule of thumb I told you guys about LEDs? 5, right? So if you've got, it's a 10 watt LED bulb, you multiply that by 5, it becomes 50 watts, then you multiply it by the number of loads that are going to be on that circuit. If it's another 10, then you're at 500 watts. Okay? Questions about that? All right. There's another way that you can do this rather than doing it on every single page. And this way is actually much easier, the way I'm going to show you. But you first have to add all your lighting loads. Then, once you've added all your lighting loads, you can, and now here's your wattage, it's doing all that, what I just told you. Once you've added all your lighting loads, you can go to what's called the Light Properties Agent. Okay, you add all your loads. If you haven't added all your loads and you go back and add more loads, just hit Reload Data. But what it will do is, in the Agent page of the Light Properties Agent, you can just simply type these things in for all your loads right there. You don't have to do it on every single load because this lists them all. So this corresponds to load number where you can do alpha or numeric characters. Type in, kitchen, sconce, whatever, and then the total number of watts that load is going to do. And this tells you it's a 0 to 10, or it's a non-dimmable or dimmable load. Yes?
With those light 2 drivers now, will you make those same features available to third-party light?
These features.
Yeah, the light copies.
Yeah. Not right off the bat, no. We won't. But it's a good suggestion, actually. So it's a future possible enhancement. Yeah, this is only, it's a good point. This is only for our stuff, right? As far as I'm aware, unless we've done something magical in the background, which could be. Okay, if you overload a module or a channel on a module, you get a pop-up error that says, by the way, you're using too much wattage on this particular channel. Okay, it won't support it. And that wattage varies based on if you've chosen a Control4 panel to put this in, if it's a dimmer, if it's a relay, and so on. So it'll tell you that, though, once you hit a certain point, it'll say, I'm going to change that back to the old value because you've now exceeded it. Or it'll tell you circuit 2 is over the maximum wattage. All right. Questions before we move on? Okay, let's talk about dimmable light properties. Now these are something that you can do after the install. So everything I just showed you is sort of pre-install stuff that you're working on building out a report that you can print out and give to an electrician on what he needs, how he needs to assign this. We're not done with the pre-build, but this is something that you can do either before or after. And that's this click and hold ramp rates, the range levels, all these different things, LED information, that can be done either before or after. Okay? So it doesn't matter. You can do those either place. So I'm going to skip through that. If you're using a power booster, you check that box. From what I gathered, it's not common here. The override level. So this defines, okay, the level of, or the on-off state of the load that it'll be set to when the module override button is pressed. Now you can set that up right on the panel itself by just pressing and holding in the module override button for 5 seconds, and it captures whatever state that system is in. So if the light's on, it captures that. But if you want to set it up here, you can do that here as well. So whenever the auxiliary override is engaged, that's what this will go to. There's the auto detect. We've talked enough about that today, so I'm going to go on. Programming based off of energy values. Again, it shows the same energy type values that the next generation lighting showed. Non-dimmable properties. These are very similar to the, the relay is similar to the dimmer, so I'm not going to go heavy into this because there's more important stuff to show you guys. 0 to 10 volt properties, same thing. Okay, so we'll skip through that. This is different, where you're choosing if it is, you're gonna rely on the fixture data sheet or consult with the electrician to know if you're going to choose 0 to 10 regular, 1 to 10 regular, 0 to 10 inverted, or 1 to 10 inverted on the load type. Again, there is there's a standard, but there's 4 different ways this could actually be implemented. So we're going to do whatever you need to do. This override level, same thing. External relay. If you're using an external relay, you're going to check that box, and that will put it into the reports so that the electrician knows that they have to wire for it. Okay? If you're not using an external relay, that means we're assuming you're going to use the Control4 relay. So that's what that's for, is you're going to have to wire an extra if you're using that external relay checkbox there. We did energy usage. Okay, so we've added the lights. Now we need to add the actual panel modules themselves, whether it's the dimmer, the relay, the 0 to 10, and then we connect the panel modules to the lights, and then we tell the system which panel cabinets those modules are going in and where. So that's all still done in sort of virtual mode here. So we've gone and now we've added what we think are enough dimmer and relay modules, along with a 0 to 10 and an Ethernet switch, to account for the number of lights that we had. Now this is not an exact science that you'll get right on the first time every time, because it may turn out that you're overloading a module. Ideally, you'd be able to use every line to its maximum capacity in every module. That will not happen in the real world. Okay, it just will not happen. You're nodding like, yep, I know. Unless you're some type of, savant at this, it's just not going to happen. Because there's different things that will always come into play. You won't be able to maximize every module to its full potential, so you're probably going to end up getting an extra module or 2 in the project just to account for all the different types of lights. So I just want to put that disclaimer out there. But Composer will help you do the best that you can to make sure that you maximize all those lines as much as possible. So you put the dimmer module in. What you're going to see is the voltage. You're going to set up the voltage. It will actually tell you, once you're connected to it, also the measured voltage, the frequency, the temperature it's at. Just for you guys, it reads in Celsius, so you don't have to change that or anything. If it's in overtemp fault, if it's in a Control4 panel or not. Okay. And then this is where you type out where you want the auxiliary override switch to actually be installed. And that shows up in the report. So you say, all right, I want to put this, in the kitchen pantry closet or something. Right? Goes out of the way, but easy to get to. And how many circuits are coming in, either 1 or 2, into the dimmer. So we're going to move on there. See, I just said all that, and I didn't need to because all these slides say it for me. All right, the relay module. Same thing. You're going to set up the nominal voltage. You're going to see, when you're connected to it, it'll show you the temperature reading. If there's an overtemp, You're going to put in the auxiliary override switch location, example, master bedroom, closet. You've got 4 circuits that come into this, and you define if it's a 15 or a 20 amp breaker. Okay? Different than the dimmer, right? The dimmer can take 1 or 2. The relay requires 4.
Is the measured voltage revealed by cutting the light off the device?
Yes. Yeah.
Same frequency?
Yes. Yeah, it updates in kind of real time while you're looking at this. All right. 0 to 10 volt module. You also see the temperature reading there. Auxiliary override switch location, same as the others. Okay. The Ethernet module has no properties you need to worry about. Okay. You'll still add a driver. The 485 bus gateway, there is no properties to set up as well, but you still add that to account for it. Because those take up, the gateway takes up a half space in the DIN rail panel cabinet, and the Ethernet module takes up a full space. 48 bus power supply, there's no properties to complete there, and there is a 5-minute video on how to install that. Because what we've done is we've actually are selling or including we're not including, but we're selling an adapter kit. And so if I can just, I'm going to turn this off because I don't want it to go really loud. Where it's going to go is at the bottom of this panel, and it's sort of a bent piece of sheet metal that you're installing it into that allows you to route the low voltage wiring on one side and the high voltage wiring on the other side. Okay? If you have 2 power supplies, the other one needs to be installed in another panel or some other location because the 2 won't fit into this. Just a single power supply will fit in per cabinet. So there is like a 5-minute installation video on the university that actually shows it being put in. It's part of the full panelized module, panelized lighting module training. Okay, connections. This is where the trial and error comes in, figuring out which loads to connect to which module to maximize that module's use so that you get the full wattage out of that module that you can, right? So when you go to connections, you're going to see, and it's probably easiest to click on your 8-channel dimmer, and you'll see the 8 channels here, and then you can bind each channel to a load. Now as you start binding it to loads, over here on the right, you'll see an update that in circuit 1, we're going to allow you 1,440 watts or 2,880 watts or whatever it is that's allowed in your area. You've used this many, and you've got this much available. Okay? In circuit 1, we're going to allow so many dimming watts. Now, dimming watts can change or be different than your allowed watts based upon if you're using our panel cabinet or if you're using an arc fault circuit breaker, which you guys won't be using. So that's really what's affecting this, is this arc fault circuit breaker affects dimming watts versus total allowed watts. And then you're going to see the same thing for circuit 2 right here. Now you can filter this by showing, and I think I've got a, there it is. You can show unbound items, you can show the bound items, you can show dimmable and non-dimmable lights. So if you only wanted to see dimmable lights that haven't been bound to a module yet, you check dimmable lights and unbound items, and so down here you don't see all the light loads. It's a quick way to filter so you know what's left to be bound to a dimmer. Okay? Or if you're on a relay, you would check show non-dimmable lights. Alright, so there's a filter example for you. Viewing wattage info. So this is a little blow up here of this where you can see how much is available, how much you've used on circuit 1 and 2. Now again, it's sort of like a juggling act here, because each load is going to use a different amount of wattage. So as you connect each load differently. Now the other thing you want to try and do, though, is make sure that loads in similar areas of the house kind of go into the same panel modules. Why would that be important, you think? Rooms that are connected to each other, try to get those into the same panel module. Any idea why that would be important?
So you're oscillating rate, oscillating rate.
Yeah. For the override also, right? something goes wrong, the override then turns on those lights in the house. It doesn't like turn on, you know, a random one over there because you happen to hook it into the same panel module, right? So that's the whole hard part of this, is you want to keep them sort of loosely grouped together, plus maximize the wattage usage. All right, we talked about total watts allowed. Dimming watts is different when you're using the arc fault breakers. And your module watts is down here. So your complete, how many are allowed, how many have used, and what's available. All right, I showed you this error before. If you overload a circuit based on a connection, like you just dragged something and said, nope, that puts me over the maximum wattage for this circuit, it'll give you that error message. So you have to connect a different load to that module. If you, okay, you get this error here that says binding a Control4 relay is not allowed while use external relay is checked. I'm going to unbind that. So remember when we were on the 0 to 10 volt module and we were saying if we were using Control4 relay or not, or were we saying external relay? If you uncheck that, that's when you're allowed to bind a 0 to 10 module to a relay module. Okay? If you don't have that guy checked, or if you do have that guy checked, we're not going to allow you to bind our module to our relay, because it's expecting that you're going to bind it to some other external relay. And you won't make that connection in Composer because there's no way to physically represent that other relay in Composer here. All right, you're going to add your 2 or your 5 slot panels. So we've kind of built this backwards than what you might think, right? You might think, well, I'm going to add the panel first, then I'm going to add the modules to the panel, then I'm going to add the light loads to the panel. We've done the exact opposite. We've added the light loads first to represent what's on the lighting plan, and we've added the modules to account for those, and now we're going to add the panels to account for the modules. All right, so once you've got the panels in there, you can determine, or you can say, all right, I've got a 5-slot panel. In slot 1 is my 8-channel dimmer. The first one, 8-channel dimmer. The second one, here's the 8-channel dimmer. The third one, here's the 8-channel relay. So this also prints out on the electrician's report. So he knows in slot 1 on the top of this panel is this particular dimmer module. Here's another dimmer module. Here's a third dimmer module. Here's a relay, and so on. So he knows exactly how to wire that up. All right. What is this one? Consideration must be taken into account during the initial electrical wiring. The bus Ethernet gateway and bus power supply do require panel space. So we mentioned that already. Okay, here's the reports that come out. When you go up to the file menu, there's a reports menu in Composer, and you can do panelized lighting. A panel report, a module report, and a load schedule. So again, that's tools, reports. You can do panel, module, and load schedule. Those things can be printed, or they can be exported to a PDF. It can also be exported to a Word doc or an Excel spreadsheet. So here's what a sample one looks like, where you've got your panel report, 5-slot panel, 2-slot panel, where it's going, what's connected to each slot, where the slots are here. Okay, and as you go. Let's see, what is that? Oh, Composer 251 will also include the bus Ethernet gateway and the bus power supply. Before 251, it did not.
Does that mean that's like on Spice as well as sort of preserves it on the one panel?
That's correct. Yep. So here's the module report then, where you go in and you'll see all the load numbers. Remember, those can be the alphanumeric, the load name, where it's going, how many watts, if it's hooked up to a power booster or not. The amps that are coming in as far as each circuit goes, to line 1 and line 2, and the auxiliary override switch location for this, if there is one defined. Okay, so it's a nice little report that you can get printed out for that. And then the load schedule continues, all the way down. How many watts it's going to take again, where it goes, which circuit it goes to, or which panel load it goes to in that panel module. Okay, wired keypads. This is something that's completely different from anything you've experienced before as far as identifying devices in Composer. So I know it's the end of the day, but let's pay a little attention to this so when you do get to it, remember, that happens a little differently than any other device. So you're going to add the keypads, the wired keypads to the relevant rooms, and you'll create the keypad, you'll give the buttons names, okay, just like you would expect. You'll add the Ethernet 485 bridge, okay, same normal bindings that you do before. So you're going to add that, after adding the keypads, they need to be bound to the gateway. So any keypad that's bound to that gateway, you're going to bind them all to that same gateway. Okay? That's what you do first. Then, you're going to identify them. Well, first you do have to identify the bus Ethernet gateway, I guess. So you either drag that in via the STDP and discover devices, or you identify it here by just pressing the button on it once you have that screen open. So your gateway's open, or identified. Now, when you go onto the gateway screen, you're going to see a whole list of unidentified keypads. And when you identify them, they get moved over into the identified keypad area. So what you do is you highlight right here. You're going to go to the properties page of the Ethernet bridge to identify these keypads. So again, it's completely different. It's not in the connections area. You're going to see this identify and unidentified and identified box there, right? And how you do this is you select a keypad, then you click on the identify button in the bus Ethernet gateway properties window. Okay, so I'm going to select the keypad, click a button on the device now to identify it. So you're actually going to physically go to the device and identify it. Now if you picked the wrong keypad to identify it, because remember the keypads are all going to have names, where they're at. If you picked the wrong, you meant to identify the kitchen keypad and you entered the dining room keypad, you can just hit re-identify. Select the keypad, hit re-identify, and then go to the kitchen keypad and identify that. Okay? That's how that works. So you highlight the keypad, hit identify, go to the keypad and touch it. It moves into the identified device column. Go to the next one in the unidentified devices and highlight it, hit identify, touch it. Again, very different than what you're used to in the connections area of Composer because it doesn't happen there. Questions about that? Okay. All right. Like I said, if you misidentify something and it moves over here, oh, that was the wrong one I touched, and the driver moved over, just select it, hit re-identify, and retouch it. Renaming the button is very similar. You just rename it right here in the events here, or the name, and then those show up under the keypad events. This button naming will also be used for the engraving process. So that's a little different too. Remember, you in the wireless stuff, you named it and then you put something in the engraving area. This is going to adopt the same functionality there on this properties page. Then you configure a fallback by binding the keypad button or buttons to, there's a fallback on and a fallback off. Okay, and you're going to define which buttons. So button 1 could be on, button 2 could be off, and you're going to bind those to a lighting device. You can assign multiple lights to a single button if you want. And these only kick in. These fallback bindings only kick in if a control fails and there's not the standard button linking that's going on, which is kind of nice. All right. We talked about lighting scenes. What time have we got here? 5:15. Why don't we do this? There's an advanced lighting scene agent. We've got some training on it on the university. So before I launch into that, I want to answer any questions you guys have outstanding for the day before we get into a new topic here. So tell me what else you got. Yes.
Working on topic, multiple ZAPs in a project. If you are using a third-party non-CPU-based lighting control system, you use Control4's control system.
Yes.
One of the things that we do is we holder he uses, creating that for the room, better than to the room having options that.
Yes.
Is that ever going to change where, I know it's a Zigbee issue, but where Zigbee can mesh via Ethernet? So if your controller justifies the client saying, particularly if you never room, there's a concrete slab in the middle, we want to throw some extra Zigbee devices in just so we get our signal around. It's sometimes a little bit of a pain in the arse.
Yeah.
So can we ever expect to see Zigbee to Ethernet back to Zigbee? Or is that too high?
Do you want to comment on that one, Eric? Did you hear the question there?
Not part of the question.
Zigbee to Ethernet back to Zigbee?
Yeah, currently the situation
I'll point you back to the university to get more information on them. But I'm going to skip into advanced lighting scenes here and tell you some of the new things that are available. Scene tracking is available, where we track if a scene is active or not. And that doesn't, we don't have to rely just on next generation lighting for that. That can be our old lighting. We can track that. Scene toggling is something new, where you had to kind of do workarounds in the past to get scenes to toggle. Now you can build in a toggle scene and define whether that's active or not based on what the active scene is. We've got scene renaming and a graphical representation of scene actions, meaning a visual representation of what the scene does over time. These are new. Ramping and fading of scenes, so where you press and hold and the scene actually ramps up and fades down, only for next generation lights and recent and panelized lights. Okay. Delays within scenes, where you can have the scene fire off and then you can do a delay. So picture in your mind a long hallway where they hit a button and the light comes on here, and as they walk down the hallway, the lights are going on in front of them, and then seconds later the lights are going off behind them. Okay, so that is sort of a delay in the scene, and then something else happens after that. I don't know how many, it's sort of to me it's like a spy movie thing, right? If your customer really wants to do, they have a long hallway and want to do that, that's a great use for it. Other uses, I'm not sure. But multiple actions for lights within scenes, that's what I just told you about, and then also the flash option. We can actually flash the lights. That's part of an option. It's not something that is complex to do programming on. So, for example, the alarm system is in an alarm state, right? It's been armed, and now something's gone wrong. You can flash the lights. All right, so it's called advanced lighting. You do the same as always. You enter a scene name, and then you choose the light loads that you want to have access to it, and then you get something like this. Okay, so let's break kind of some of these things down here. So apply to means that you can adjust the setting for one light, like what the delay is in the ramp rate, the level it goes to, and you can hit apply to and apply it to all the rest of the lights if you want to. So that's sort of a global function within the scene itself. So easily, these guys can adopt what's there. Tracking. This is where people get a little confused. Okay. Tracking, we're no longer saying a scene is on or off. We're getting rid of that terminology. We're saying a scene is active or it's inactive. And we can track active or inactive. Scenes that turn lights, that turns off. So the reason we got away from this is like an all-off scene. Is the all-off scene on? Yes, that means the lights are off, right? And so you're using off and on, and it gets confusing. So is it active or inactive? You can use scene tracking to have these LED buttons follow the state of the scene just like they follow a load state. So you can bind these to a scene instead of to a load. And you do that in connections under bindings. You bind it to a scene instead of to a load. You can have the UI indicate whether it's active or inactive. It does that automatically. When you go to the UI, you'll either see a blue line light up next to the scene name or not. That means the scene is active or inactive. You can program based on a scene being active or inactive, and you can trigger when to toggle that scene here. So lots of cool little things. So my scene's active there. Got a green light on or inactive. So when should a scene be active? Well, the big answer is it depends. All right. So here's a scenario. You've got a basement scene, and it's at the top of your stairs, And if any light in the basement has been left on, you want the basement scene to be active so that it's easy to tell just by looking at the keypad at the top of the stairs. If it's illuminated, then you can just turn off the lights with one button click, right? You know that the lights are, there's at least one light on in the scene. You can quickly turn that light off by hitting the button that has an active LED. How about a master bedroom scene that you track where it's active as long as all the lights are on at some level? So I'm going to skip to this guy right here. This is where people get a little confused. So, is this scene tracking all the loads or any load? Meaning, any load can be at any level here below, and then it's going to be active. So, you first go out to decide if it's all loads, all the tracked loads, if you check this, all the loads below that are being tracked have to meet their tracking condition. And the tracking conditions are, don't track, the load is off, the load is on, it's on at any level, is on any level, on at a level, a certain percentage, or at the scene final level. So this is where it gets really fun, because you have to pick, do you care, is that scene active if it's on at any level or if it's on at a specific level? Maybe you have a dining room scene, and the customer wants it so that the light is always on at a certain, if it's at 75%, that is my dining room scene. But if it's at 74% or 76%, it's not my dining room scene, right? So you get to figure out with the customer, right, are you tracking this light at all? Are you tracking it? It could be on at any level. It can be on at a certain level, or it can be on at the final level of whatever the scene ramp is. Okay? I know I'm completely losing you guys at this point. What I recommend is that you play with this a bit and see how it works. What can happen, though, is you can easily set up a scenario where you have a light, like a kitchen light or a dining room light, that's part of multiple scenes. And if you just track that at any level, multiple scenes now can be active, which is okay, but if you're trying to toggle a scene, and you've got two scenes that involve that light that are both active, okay, the toggle function won't work, because for the toggle to work, it needs to know this scene is the only scene that's active, and I want to toggle to the opposite of what it's at. And anyway, you'll get it when you start playing with this, right? So, don't track means this load is not included in scene tracking. Okay? It's part of the lighting scene, but I'm not going to track whether or not it's on or off, so I don't care. It just, when I fire that lighting scene, it turns a certain light on, and then from that, I don't care. I'm not going to track it. Okay? Is off just means that the condition for the light is true when the light is completely off. It's at 0. Tracking at any level just means that it's got to be greater than 0%. Final level means, again, if it's ramping, it's at that final level percentage, whatever that final level percentage is, that's when we're going to start tracking that. And you set these options for every single light that's part of the scene. So for that basement example, if I wanted to know if any of the lights were on in the basement, I would choose any load, and I would choose is on at any level for my basement lights. And that way, it doesn't matter if someone came through and turned off one or two of the lights. If one is still left on, I can see that on my LED status. It's on, and I can quickly go and hit toggle, and it turns that light off. All right. Let's skip that. So here's the things that we think you guys will use the most. Any load with each load set is on at any level. That's the one I just described for you, that basement one. All loads with each load set is on at any level. So there's the second one. All the loads got to be on at least some level, and we'll track that if you set it this way. Or all loads with each load set at scene final level, meaning that specific scene got invoked and all the loads are still on that final level. No one's come and adjusted any of the loads since then. Because if you've got all loads with each load set at scene final level, and then somebody goes over and manually hits a switch and turns a load on a little bit more or down a little bit more, all of a sudden that scene is no longer active. And now you have the ability to invoke the toggle scene via programming or a touch panel button, or something on the GUI or keypad or whatnot. So we're constantly getting feedback on what light levels these guys are at. That way, we show you on the GUI or on the LED status if a scene is active or inactive. So in this example there, we're going to bind this LED to a keypad button. When the scene is active, the bound LED button will be blue. When the scene is inactive, that bound LED button would be black. Okay? So you can quickly get a visual indication of the status, and then you can now define what you want to do when you tag that button, if you want it to do a toggle scene or not. So with scene toggling, it activates again based on if the scene is inactive or active, right? Here's where you set up toggle scene right here. If you hit create default, what it's going to do is it's going to create a scene that has all the light loads participating in it as your scene right now, but they're all off. Okay, that will create a toggle scene. You can also pick a completely different scene from this drop-down list to be your toggle scene. Maybe you already created an all-off scene. Maybe you want to, you've got two different scenes that you want it to toggle back and forth between, and neither of them is completely off. Just depends on the circumstances. So you either create a default or you choose a different scene to be your toggle scene. Okay? You want to use caution because you want to make sure the toggle scene doesn't leave the original scene active. Right? If you can do this by having a bathroom scene that sets the lights to 95% and uses any load on at any level. And your toggle scene could turn the lights off, but it leaves one light on at 5% for a night light. Well, these two guys can't toggle back and forth between each other because you've said any load is on at any level and you've left one on and the toggle scene on at 5%. So both scenes are, in essence, it would want both scenes to be active at the same time, and it can't. Alright, so the bathroom on scene is still active after the toggle. You won't be able to reactivate it from the button bound to it because you've always got this guy that's going to be active. He needs to go inactive before you can do a toggle. So make sure, again, you don't set up things that are both, on toggles at least, you can't have two lights that are always going to be tracked on at any level. It's just not going to work. Okay, it is 5:30, so I'm going to, we talked about that. I'm going to close up here because I told you guys we'd get out about now. But I will stick around and answer more questions that you have about either this agent. We have that survey sheet. If on your way out you want to drop it off to Paul and Eric, they'll give you a little parting gift back at the table there. We are not giving away controllers, I apologize, but something that's almost as cool. Speakers. No, I'm just kidding. So thank you guys again for all your attention. Like I said, I'm not going anywhere right now, so if you have more questions, I'll leave my computer up. I can go and show you whatever you want to in Composer. I know it's been a really long day. We very much appreciate your business. Love coming down here and hanging out with you guys.